Welcome to 10.1 worksheet. Here we go. Let's go through some of these problems together. How are chords and secants alike and how are they different? Well, here is a circle. And this is a secant. And this is a chord. So they're similar in that they hit the circle twice. You got 1, 2. Similar in that they hit the circle twice. They are not similar in that a secant is a line. It goes on forever. And a chord is a segment. Now, part of a secant, the inner part of the secant is also a chord. So a secant contains a chord. This is a chord right here. The secant in general is a line. So again, the difference between a secant and a chord is the difference between a line and a line segment. All right, complete the sentence. Coplanar circles have common center are called, if two circles have a common center, there's a special name for those. Those are called concentric. Which segment does not belong with the others? Chord. That's a chord. A radius. That's a radius. A tangent. A diameter. That's a diameter. A tangent on the outside of the circle. So I'm going to say tangent is the one that doesn't belong. The others are on the inside of the circle, and the tangent just kind of touches. All right, next. Use diagram. Name the circle. We're just going to call this circle C. Circle C. Name two radii. One of them is segment CA. That's one of them. Name the other one. Name two chords. Here's one chord right here. Segment AD is a chord. You name the other one. Name a diameter. Segment AD is a diameter. A diameter is a special chord, which is why it's the answer for both of these. Name a secant. Now, these are all segments, right? And a secant is a line, so I'm going to change it. Line GE. That's not a secant, that's a tangent. Sorry, line BH. Line BH is a secant. Line BH. Name a tangent and a point of tangency is right there. So you can figure that one out for yourself. There's the point of tangency right there. Copy diagram, tell how many common tangents circles have. So this one's like one we did in class. You can do that one. Common tangents. If I draw a tangent to like this circle on the inside, it's not tangent to the outer one. There is none. There's none there. What about common tangents here? There's 1, 2. Ooh, is there any others? Can I go like through the middle? No, I don't think so. I think there's only just 2. Okay. You do 14 on your own. Tell whether this is a tangent, which means the question is this a right angle? And this one obviously is. That's the old 3, 4, 5. So this one is, yes, that is a right angle. It has to be. Oops, I'm out of the picture. That is a right angle. It's a 3, 4, 5. What about this one? Is this a right angle? That's the question. Maybe. Let's see here. We can do this real quick in our calculator. We can just plug in and see if 9 squared plus 15 squared is equal to 18 squared, which I don't think it is. So this is no. 9 squared plus 15 squared does not equal 18 squared. You can write that down to show your work. That's weird. Same thing here. Now, be careful. If this is 20, then that makes that 20. So it makes this whole length 40. So you're going to compare 40 squared with 48 squared and see if that's a right angle. So, I mean, you're going to do it like this. I'll just do it. 40 squared plus 48 squared. You're going to test that against 60 squared. Nope, not the same. This one's on you. Don't forget this part right here. All right, next, 23 and 24. These get a little complicated with the algebra. So find the radius. So we're under the assumption that it is a tangent. This is a right angle. And so we're going to set up r squared plus 24 squared. That's a squared plus b squared equals c squared. That would be r plus 16 squared, like that. So you got a squared plus c squared equals, sorry, a squared plus b squared equals c squared. So we're going to work that out. That's r squared plus 24 squared, 576. And then this is r plus 16 times r plus 16. So don't fall for that silly algebra mistake where you distribute the square. You have to distribute the r. So that's r squared plus 16r, and do it again, plus 16r plus 16 times 16 is 256. Okay, nice thing here, these r squareds cancel each other out. You can subtract the 256. So 576 minus 256 is 320. Over here you've got 32r, which means that r is 10 for that problem. All right, basically do the same thing for number 24. R squared plus 9 squared equals 6 plus r squared. R equals 10. If I plug in 10, it's going to make sense. This is 10, which makes this 26. This is a 5, 12, 13 triangle, if you remember that. It's 5 times 2, 12 times 2, 13 times 2, so that works out. All right, this is using theorem 13.2. Sorry, what did I just say? 10.2. If I want to do number 29, knowing that these are tangents, okay, tells me that these are the same length. So I can do 2x plus 7 is equal to 5x minus 8. Subtract, add, divide, x is 5. I can check my work by plugging it in. 2 times 5 plus 7 is 17. 5 times 5 minus 8 is 17. So these are both the length of 17. Okay. Do 30 next to it. 33. Describe and correct the error. They're saying because 11 squared plus 60 squared is equal to 61 squared, that this must be a tangent. And the problem with this is that they have their right angle here. To be a tangent, this is theorem 10.1, the radius and the tangent line have to have the right angle. That has to be the right angle. They have the right angle in the wrong spot, is what happens. And so this is not a tangent because you could obviously see it. This would have to be the longest part of the right triangle, and that just doesn't work. So basically, they had the right angle in the wrong spot. It's the radius and the tangent that have to make a right angle, not whatever this is. Here, describe and correct the error. We've got a radius. Find the radius. This is a diameter. So we do have 2 radii, which does make this a right angle. And they did 39 squared minus 36 squared equals 15 squared. So this diameter is 15, which makes the radius half of 15. 7.5. They forgot to find the radius. They found the diameter, but they didn't find the radius. 37, classic question here. So a couple things. This is using theorem 10.2. We've got, this is 3.1, which makes this 3.1. This is 3.3, which makes this 3.3. Now take your 4.5 and subtract 3.3 and you get 1.2. So that makes this 1.2. All right, that works out. 1.2, 1.2. It's a little check there. Take your 8.3 and subtract 3.1. Whoops. Yeah, 8.3 minus 3.1, 5.2, which makes this 5.2, which makes this 5.2. And I think that's everything you need to figure out the perimeter of that shape. Name the red minor arc and find its measure. Then name the blue major arc and find its measure. So the minor arc is arc AB. And its measure is 135 degrees. The major arc is arc ADB. That tells you that you're going the long way around the circle. It'd be helpful if I had this in the picture. Arc AB is 135 degrees, whereas arc ADB, the longer way around the circle, is the major arc. And if this way is 135, then the other way is 360 minus 135, 225 degrees. You can do 4 on your own. Okay, next. Identify the given arc as major arc, minor arc, or semicircle, then find the measure of the arc. BC is a small minor arc. So we're going to say minor, and it is 70 degrees. Let's do 14. 14, EBD. So we're going to start at E. We're going to go through B and end at D. So that's this whole thing here. That is a major arc, and it is equal to 360 minus 45, 315. Okay, you can do the rest of those. Exercise the following. Find the value of x. Well, it appears that this is a diameter. It does appear that way, which means we've got 180 degrees here, which means 2x minus 30 plus x equals 180 degrees. So we have 3x, add the 30 over. Looks like x equals 70. And then find the measure of the red arc. I'm going to plug in 70, 2 times 70 minus 30 is 110. So that's 110, and that's 70, and that works out. That makes sense, because those have to add up to 180. So the final answer is 110. X was 70, and the final answer is 110. So you have to figure out what x is here, use 360 degrees, and then find out that red arc. I think that is it for my homework help.